is. I'm not saying he isn't, but I just don't think he fit into any system right now.
Or
Like
or
you look,
the system
you
has
look at the,
the
you
system
look at the
has
top team, right?
to fit into
The,
him.
I mean, probably the only system that fits into him is the Arsenal system, but we're
Maybe
not
Man
winning.
City, maybe
No, we don't have that much money.
Man City.
Uh, Man City, right?
Yeah.
The whole problem with Man City last season
Uh-huh.
is they don't have a center back. So Fernandinho has to fill in on center back, and then now they suddenly don't have a defensive midfielder that can defend and create forward chances. That and then Messi comes.
Mm.
They're doing even worse
Okay.
on defense,
Uh-huh.
right? Because Messi doesn't defend.
Uh-huh. Mhm.
Let's just get it out there
But
that
wait,
Messi, like you can say how good he is. Messi doesn't defend.
but
Okay,
Man City had a big problem up front, right? The Sterling.
no,
Did you see
they
the
they
Sterling?
don't they don't have a problem up front because as long as Kevin De Bruyne is there,
Yeah.
nothing's gonna happen, right?
But Sterling
They're gonna
can't
have a good.
convert chances, right?
Well, he has convert. The thing is, like he has converted chances almost all season by this point. I mean, like he's not bad at finishing. He's just bad at finishing at that moment.
Oh, right.
It's such a shot because he did good this season. He didn't do bad this season,
But people
right?
remember him for that particular moment.
Yeah. It's such an easy shot.
Uh-huh.
That's the thing, right?
Uh-huh. But he missed.
So I
He missed.
yeah,
I mean, he's not a finisher, I would say. How many
he's not a
goals did he
finisher, but
score per season?
I think he's on the leaderboard. Let me
What
check.
is his statistics? Let me check it out. Sterling
Let's
goals
shoot them.
per season. Look at this.
Yeah. He's Jimmy Vardy, Aubameyang, Danny Ings. He is 20th.
Okay.
He is fourth. Scored 20 goals. It's not bad,
Yeah.
right? So it's good.
Hold on. For the three, for the past 3 seasons, I would say he just like, you know, fairly.
Around 20 goals. 20 goals. It's
Yeah.
good. It's not bad. It's pretty good.
I would say he's good, but not that great.
But he's good. He's enough. They have like Aguero and stuff.
Aguero is like 30 or
Yeah,
25.
he's 30.
Oh, okay.
Aguero needs replacement.
Oh,
But right now, Man City's offense is good. The whole reason that they can't win
mm,
like the past season is because of the defense.
mm,
It's because Fernandinho has no substitution, and then he has to fill in the center back spot. So they lose all, and then I think Rodrigo is hurt. So everything had just fall apart.
mm.
And like with Messi there, they're gonna do even
But
worse.
with such a big budget, how can Man City afford to 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 not have good players at the back and in the midfield? I mean,
It's
they
tough
must
right
top
now
up.
because you can't think of a good player that's not in a good defender that's not already in a big club.
What I'm saying is like they should have a good backup, right? But seems to
But
me
they don't.
they
Yeah,
yeah.
yeah, because they don't. Like everybody's hurt. That's the problem. That's the problem they're desperate to find out. As I as like I they need to find a decent defender, like two, maybe three decent defenders.
Mm-hmm. Wow.
Because Ottomendi has proved that he is pretty shit.
Okay. All
Yeah.
right. Okay. So so I think today we would go to the new chapter after probability. So let's learn something new on linear modeling. Okay.
Yeah.
I think you haven't learned this chapter before.
No.
Yep. So I think
Yeah,
it's
I
good.
do think that Messi is good
Mhm.
for Arsenal because Ozil is leaving.
Wait, Messi is going to Arsenal?
No, I
I
think he
can't
should.
I can't imagine this scenario to pan out. No
I
way, man.
I know, right? But right now, Arsenal is the team that he can fit in
Okay,
because we're offloading. Hear me out, okay?
wait.
Like
You have to know that Messi has to agree to go to Arsenal.
yes, I know. I'm just saying.
Uh,
I know it's not gonna happen.
Uh-huh.
I know Messi is not going to Arsenal.
Uh-huh.
Going to Arsenal will work for him the best.
All right. I mean, from an Arsenal fans' perspective, I can
No, no,
sometimes.
Arsenal fans' perspective.
Uh-huh.
We're rebuilding, and
Mm.
there's an empty Mesut Ozil spot that
Uh,
he can fit in right away because Ozil doesn't defend, Messi doesn't defend.
you
And
are an
if
Arsenal fan, right?
yes,
Yeah.
I hate I don't like Mesut Ozil. I used to like him, now I don't. After he said
Yeah.
the
Okay.
quote best shit,
Okay.
okay.
Okay. So nothing to do with
He's a
his
terrorist to me now.
professional.
Okay, Mesut Ozil right now to me is a terrorist. Okay,
So nothing to
and
do
then
with his
yeah,
professionalism. Everything to do with his personal characters.
yeah, and also Mesut Ozil doesn't play defense, so I don't like him anyways.
Mhm.
And I mean like Lionel Messi is a better player than Mesut Ozil,
I
and
can't
we
imagine.
have and then there is Torreira. We do have Aubameyang. We do have like I said, we still have them.
I
We
think
have
I think
Torreira in
I
the
think
midfield.
Messi will go to PSG. Yeah.
Oh, I think PSG. If they do, like PSG in big trouble, like
Uh,
the FFP,
uh-huh.
like PSG is gonna be in big trouble.
Oh,
Like there's no way anybody can win a case that suggests like there's a 70 million price tag,
oh.
700 million price tag on Messi.
I think he will agree to
Unless
what he said.
unless he leaves on a free, there's no way that he's transferring.
Okay. All right. Okay. So let's take a look at this new chapter, which is called linear modeling. So we need to like
And also, Arsenal won a Community Shield.
yeah, I know. They I mean
Ah,
they won the FA Cup and then they won the Community Shield and
and
then
we won a
people
double.
to to um start to
No,
hope for better things ahead.
I'm not hoping for better things because
I mean
the
you
two.
you expected
I
the worst and the
No, I
worst
don't
didn't
expect the
happen.
worst. Yes,
The
the
worst didn't
worst
happen.
hasn't come yet because these two cups, FA Cup and Community Shield, is not enough to keep Arsene Wenger in his job.
Yep.
I don't get why people are excited because Arsene Wenger is gone, but he still won Community Shield, but he still won FA Cups. Like what's the point,
The reason
right?
is you guys expected the worst, and then the worst didn't happen. It's
The
about
worst already happened. We're eighth in the league. Isn't is if it's not because of the ref, we don't have Europe at this point, right? We won the FA Cup
yeah.
because of the refs. It's not so difficult to admit.
The
We
worst
won
the worst
we
is
won
not a double, right? I mean, you guys won the double. Okay.
no we won the
Oh,
FA Cup because
yeah.
because of the ref. We were not the better team.
Regardless,
The,
you guys still, I mean, Arsenal still won, right? That's what
yeah,
matters.
we did win. All right, we did win. I mean like I get that. We did win. But we were not good.
Yeah.
The same cup is not enough to keep Arsene Wenger and
Yeah.
his job. And now somebody come here and tell me that oh my god, this is so good. We're winning something. I said no.
You guys won a
Like
double. You know, it sounds like a double.
it's not a double. Community Shield, nobody give a shit.
I know.
And the Community Shield curse is still up because you win the Community Shield, you don't win the league.
Oh,
The curse is still going on.
okay.
And uh
You are hoping Arsenal to win the Premier League. Wow.
no, I'm not hoping so. I mean like I don't think I think Chelsea is winning it this year. I
Ah,
don't think Liverpool is
they
winning it.
got a good defender.
Yeah.
Okay.
I think it's really hard to defend right
All
now
right. All right.
because like it's so tough to defend
Mm,
right now. Everybody plays so similar.
mm-hmm. Yeah.
I mean it could be you this year, it could be them this next year,
Mm-hmm.
right?
Mm-hmm.
I really just I'll be praying for a top four spot, but like I
I
don't.
will say it's pretty tough. It's pretty tough for Arsenal to be in the top four. Yeah.
Yeah, but you know,
Okay. Yeah.
I just hope at this point,
Yeah. You should have big.
right?
You should have big dreams. Yeah.
I just
Wow.
I just hope that Messi comes to Arsenal.
Okay, that is a
Come
big
on,
belief.
Messi.
That is a
Come
big
on,
belief
Messi.
in the top 4 spot for Arsenal.
Come on, Messi.
All right, okay. So,
Save this dying club. We can win something.
okay. All right. So let's look at this opening problem. So over here, right, we want to see if there is a relationship between the age of an athlete and the distance this athlete can throw discus. All right. So
Right.
if you just look at the age, all right, and then you will see that most likely we will think that oh the older the person, I would say like until a certain age, the distance thrown will be higher, all right, until a
Right.
certain age, right? So a very good way to answer the questions below is to plot out all the points,
Right.
okay, to graph this table, right? So over here, they have graphed this table, and they start to observe that yep, as the age of an athlete increases, you will start to see the distance thrown by the athlete of the discus is also higher. Can you see?
Yeah.
All right. So there is a, I would say there is a positive correlationship between the age of an athlete and the distance thrown by the athlete. All right.
Right.
And over here, the independent variable is age. Okay. And the dependent variable is the distance. So what it means is the distance depends on the age of the
Right.
athlete. All right. So for the general shape formed by the dots, we can see that the age increases. Yeah. So that's what we talk about. So the age increases, and so does the distance thrown. All right, until
Yeah.
a certain age. All right. Now, this relationship is called correlation. All right.
Right.
So correlation refers to the relationship or association between two variables. All right.
Okay.
So the age varies and the distance varies as well.
Okay.
All right.
Yeah.
Okay. So over here you have some general pattern. Okay. For this, you can see there is an upward trend. Do you see the small hand? Do you see the small hand
Yeah.
moving? All right. So you see an upward trend. Okay. Even though it's not a perfect upward trend, you can see, but the dots scatter around closely to this best fit line, I would say. All right. And
Yeah.
over here, you have a downward trend. Okay. So the dots surround very closely to this downward straight line. Okay.
Right.
Over here, you can see the dots are basically just scattered around. Okay. So you don't see any correlationship for this curve. Okay. So I will say this is randomly scattered. Okay. Over
Right.
here is downward trend. Over here is upward trend. All right. So now this is about the direction. So it's either upward trend, downward trend, or no trend. Over here is about linearity. Okay. So linearity is how straight. Okay. So linear equation is y equals to mx plus c, right? So let me get
Yeah.
this out. Let me get this out to talk about linearity. Let me go to PowerPoint. To get this to a PowerPoint. All right. So over here, besides direction, which is like either upward, downward, or no relation, then
Right.
we will look at the linearity of uh, the curve. So over here, I will say this is pretty linear.
Okay.
The reason for that is linear equation. Linear equation has this general formula, which is y equals to mx plus c, right? And
Right.
this is the gradient of the straight line and this is the y-intercept of the slope.
Right.
All right, and I hope you know linear equation y equals to mx plus c. Generally, we use this for the equation of a straight line. All right,
Okay.
so I hope you can see that over here for this is pretty linear compared to this. Okay, this is not linear. This is exponential. All right,
Yes.
exponential. Okay, so for exponential graph, so we are not going to talk about it during this lesson. In this lesson, we are going to use linear modeling.
Right.
Okay, so we are not so concerned about non-linear modeling in this chapter. All right, so since we are talking about linear modeling, so this particular formula will play a crucial part in this lesson. All right,
Okay.
so later on we will take a look at how we can make use of this particular formula to model let me quit this first, to model two variables. Just now we talked about the distance thrown and ages of the athlete. All right, so we'll
Right.
take a look at how we can actually model that relationship. Okay, over here, so since if we use linear modeling, okay, and then we will start to have like three cases. So for this case, it will be a strong positive. Over here is moderate positive. Over is pretty weak. All right. So similarly,
Yeah.
this is a downward trend. So this is like strong negative, moderately negative. Over here is a very, very weak negative. All right. So outliers. Okay. So this is just one term to talk about something which is a standout. Okay. Can you see a outlier here?
Yeah.
So this means most of the dots surrounds this downward trend line closely. But somehow you see that there is a dot suddenly so far away from this cluster of dots. So this is called an outlier. Okay. So which means, let's say if uh, a class of 30 students, if we talk about a class of 30 students, and most of the students score, so let's say the total score is 100%, and most of the students score like 60% to 70%, and then suddenly there is only one particular student, so most scores, and then there is one student who scores 20%. So this is called outlier.
Right.
Okay, this is an outlier. This particular student is considered an outlier. All right. So
Okay.
that's the meaning of outlier. Okay. Um, yep. So that is correlation. Okay. And now there is another term we need to learn here. It's called causation. So now that means we have learned two terms. Okay. One of them is called correlation. Correlation. And the other one is called causation. Causation. So means we need to know what's the difference between these two. Okay. So the difference between these two is for causation, there must be a cause and effect.
Right.
All right. Okay. So I'll give you an example. All right. I'll give you an example. If you push an item, so the item will move, right?
Yep.
Okay. The item will push an item, so an item will move. So this is an example of causation. The cause is
Right.
your push. So the effect is the item will move. Okay. For correlation is not so clear. Okay. For correlation is not very clear. Let me give you an
Right. Okay.
example. Let me give you an example. Um, um, let's talk about, okay, we have the pandemic now. Right? Pandemic.
Yes.
Okay. And so far we start to see what? We start to see, older people, right? Older people tend to die from the COVID-19
Yeah, sure.
virus. So what this means is, um, some statistics, they talk about, um, from all the people who die from the COVID-19 virus, so majority of the death are of older people, people like
Yeah.
above the age of 55 and above. Okay, so
Okay.
this 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 particular conclusion, this conclusion here, okay, I would say we don't have a cause and effect. We don't have a very clear cause and effect. Okay, but
Yeah.
somehow we see a very very strong correlation. Okay, but okay, when I say we see a very strong correlation, what it means is we need to get some data points out. So what I'm trying to say is, let's say if in Singapore, okay, let's say in Singapore, so in
Yep.
Singapore, age, okay, and then death because of COVID-19, okay, so
Right.
then I have to gather these data points, okay, but in Singapore, I think we only have like 27 deaths so far, okay, so it's pretty hard for me to gather data points because the
Yeah.
sample is too small. So let's talk about the USA, okay? Let's say if I manage to gather all the data points from the USA, those who die from this COVID-19, and then we tabulate the table, okay? Let's say age 25, there is one dead, like uh, probably is better to be in terms of the range, okay? So
Yeah.
let's say 25 to 35. So probably you like 1,000 of them, and then you have like 35 to 45, 45 to 55, and then 45 and above. So I'm just giving you an example, okay? So 55 and above, so it's bigger than 55. So let's tabulate the statistics, and maybe it turns out, then we start to have like 100K, that kind of thing. Okay, these numbers might not be accurate, but I'm just showing you an example. So let's say if from this table, right, what we see is we can actually draw a graph. Over here is age of people, right?
Right.
And then
Yeah.
this will be the number of deaths, right? Then we can start
Yes.
to plot the points. So 25 to 35. So I will say just I will just use this, and then we have 1,000. Let's say here is 1,000, and then here is 2,000, and then here
Right.
is 3,000. That means 3K. So we have 4K, that kind of thing. So
Yeah.
basically, for the next one is 2K, and then for the next one is this is here, and then for the next one 55, above 55, and then you see it jump up until 100K.
Right.
Something like that. So if you
Okay.
start to draw this best fit line, of course, you can actually um, uh, split this even further, split the range
Right.
even further, so that you get more data points in between for you to have a best straight line. Because over here, I only have like 4 data points, right? So
Yeah.
it's best to have more data points. But in order to have more data points, what you can do is you can actually narrow the range. You get my point?
Yeah.
Once you narrow the range, then you start to have more data points. So once you have more data points, and you will see that the best fit line probably looks like this.
Right. Okay.
Probably looks like this. Something like this. Okay. So let's assume
Right.
that the best fit line looks something like this. So
What the outlier?
now if I only have this I have an outlier here. You know why? Because I mean this seems to be the outlier here. You know why? Because
Yeah.
I really have too few data points. In fact,
Yeah.
if I have enough data points, I think you will start to see the data points will cluster very closely to this best fit line. But over here, I don't have enough data buffer. So just assume that this is the best fit line, and you will see that, oh, this is not a strong correlation, but I would say it's a moderately correlated. Meaning what? Meaning
Yep.
the older the ages of the patient of COVID-19, and then these patients have a higher risk of dying from COVID-19.
Yes.
Okay, so I hope you understand this relationship is moderately correlated. I can't say there is a causation relationship for this, meaning
Yes.
the age, old age caused the people die from this COVID-19, because there is no strong evidence to show there is a causation, but
Right.
there is a moderate evidence to show the correlation. So I hope by using this example, I have explained to you good enough the difference between correlation and causation. Okay? All right?
Okay.
Good. So let's move on then. So over here, they also have some examples of causation, like the arm length and running speed. Okay? So longer arms. So does this mean that short arms cause a reduction in running speed or things like that? You know, the kind of thing. So it's just like what? It's just like if you are an NBA player, okay? So you tend to be, I think the height of an NBA player, it matters a lot, okay? But of course, you will tell me Iverson is short, but he was pretty good, right? So he's an outlier, okay? Most of the NBA players, I will say 90% of them, the good players, the best players, they are of 1.8 and above. Okay. Of course, you can tell me who is that short guy, and he's pretty good. Kyrie, yeah, Kyrie is pretty good, and he's not that tall as well. And then Chris Paul is pretty good, but not that tall as well. But these two, I will say, they're exceptional players. Okay. Most of the players, they are good. They have to be 1.8 and above. Okay.
Right.
Right. So causation. Now we have a case study here. Okay. The case study basically is, you have this spring, and then you have this mass of this ball. Okay. And then you try to change the mass of the ball here. Okay. So you start from zero. You start from zero. Like no, that means you don't put anything here, and then you measure the length of this spring. Okay. So at zero, the length is 17.7. Okay. And then you start to give it a 50 gram, and you will start to see the length is actually 20.4.
Right.
And you give it more, 100. The length is actually 22, and then subsequently. Okay. I think it makes sense. It makes sense to us. The heavier the ball it is here, and then the spring will actually loosen a lot more. So that's why the length of the spring will become larger. And this table is graphed here. All right. So among all these data points, I think we can start to draw a best fit line. In fact, instead of estimating, we can estimate by our naked eyes, right? Or the other way is, if you can use Excel, right? Excel, there is this feature that will give you the best fit line actually. All you need to do is you just key in these values, okay? Then you can actually get the best fit line. But of course, if you don't want to use the Excel feature, what you can do is actually you can actually estimate yourself.
Right. Okay.
Something like this. Okay. How do you get the best fit line? So what you need to do is you try to link it such that your points, okay, your points has to be balanced. So over here, I think I have 1 point above the line, and then the other point below the lines. Okay, and then the rest is pretty close. All right, pretty close. Okay. So this is my estimate. Okay.
Right.
Okay. So this is the best fit line. So given this best fit line, I see that there is a strong correlation. Why? Because all the points are clustered, strongly
Okay.
correlated. Because all
Sure.
the points are very closely clustered around the best fit line, right?
Right.
That's why, can you see here? A
Yeah.
strong positive correlation. Oh, you can add in another word positive to show that it's an upward trend. All right.
Okay.
So the relationship appears to be linear with no obvious outliers. So I hope you can see that the relationship appears to be linear. Why? Because I think it generally is fits this y equals to mx plus c pretty well. Okay. Okay.
Yep.
So that's why it says it appears to be linear, because we get a best fit line, okay, and the points clustered around this best fit line very well. Okay. Next.
Right.
All right. So if we look at some examples here, especially question 2, okay. So some of the examples, the dots are already graphed for us. So I hope you can see that for this one, I think you can start to see that this is so I will say this is where this is the best. So this is a strong negative correlation, right?
Yep.
And this is there is a one outlier, right?
Yep.
And then for this, I will say this is not as strong, but moderate positive correlation, right?
Right.
And over here, pretty weak. I would say pretty weak. I would say weak. And
Is
over
it?
here, do you think it's weak or moderately? What do you
Well,
think?
it's moderate,
You
I
think
think.
it's moderate?
Yeah.
So you mean this is weak? I mean this one is weak. You mean?
Yeah, that is weak.
Uh this one I will think is quite random.
Okay.
I will say this is quite random. The reason is you see that you have this much above and you have this much below. You know? Yeah, I will say this is no relation, not even weak.
Right.
Okay, so this one is
Okay.
okay. This one is I will say more moderate. This is moderate, and then this one I will say is moderate as well. And then this one is also you know, so sometimes I will say is it's quite subjective. You know,
Yep.
moderate and weak. Okay, strong is pretty easy to identify. Strong basically is this case is strong. It's very easy to identify. But when it comes to this thing, when it comes to this one I think is strong as well, right?
Yeah.
When it comes to this, it's like moderate, between moderate and weak, you know.
Yeah.
So it's a bit hard to. I mean, things like this is quite subjective. So but go moving forward, right? We will make use of linear modeling to tell us whether it's a weak, moderate, or strong by giving us a correlation coefficient. Correlation coefficient.
Okay.
With a coefficient, meaning with a value, with a number, we can actually tell whether it's a strong, moderate, or weak. Because it's just like, you know, beauty is in the eyes of the beholders, right? So that means what I'm
Yep.
saying is like if you just ask whether whether Justin Bieber is a female or male.
Male.
Or is a male. Okay, so let's talk about Justin Bieber. Let's ask somebody whether Justin Bieber is handsome or not. I mean, very handsome, handsome, not handsome. So you ask three different people. Three different people might have different opinions. You know.
Yes.
So some might say he's very handsome, some might say he's not handsome. So if we need to go by certain requirements, let's say
Right.
short hair. I mean, this is just one example. Short hair, okay, or short blonde hair, okay, and then probably another one is fair skin, you know, that kind of thing.
Yeah.
And then the other one is 1.75 meter and above. Okay, so let's just go by this. Let's go by these three requirements. So if the person hits all these three, and then he's definitely handsome. So I guess with these requirements, right, I think there is less room for argument whether he's handsome or not, right?
Okay.
Right. So same thing. We want to have a correlation coefficient. That means a value or a number, okay, so that we don't have argument like, oh, whether this is a whether this one is a moderate, whether this is a moderate or weak, because we
Okay.
have a correlation coefficient. So if the correlation coefficient is like 0.2, you know that it's weak, right?
Yeah.
You know it's 0.2 because okay, the correlation coefficient is it goes from 0, it ranges from 0 to 1. So 1 is strong, 100%. Okay,
Yes.
0.7 is, I will consider 0.7 is still like to the strong side. But if you tell me 0.5, I think it's moderate. If you tell me 0.2, it's weak. You know,
Yeah.
with a correlation coefficient, I think there is less room for argument. Okay, so that's what we are going to do later on. But right now, so we will just like go by our subjective, um, go by our subjective perspective first. All right.
Okay.
Next, so over here, Pearson's correlation coefficient. Yep. So this is how you can actually get the Pearson's correlation coefficient. Okay. It looks very complicated. Okay. But I think when we did standard deviation, you remember standard deviation? I think we encounter a formula as not as complicated but less complicated than this. All right. By the way, this is a summation sign, yeah.
Right.
Sigma. Okay. And then x with a line above is called the mean of x. And then over here is the mean of y. Okay. So basically, if you don't want to do it manually, all right, so you can actually use a calculator. You see, over here, they give us a table to talk about whether it's a perfect positive, very strong, strong, moderate, weak, no. So exactly like what I previewed to you 2 minutes ago. Okay,
Right. Okay.
it's good to have a coefficient, a number, so that we don't have room for argument, right? Similarly for
Yeah.
negative correlations. Okay, so by using this table, we can actually pinpoint, okay, pinpoint whether the correlation relationship between two variables more accurately. All right.
Okay.
So you see this one. This one is like no relation because it's very random. Over here, you still can like draw a line somewhat, but moderate. So the strong one is like you will tend to see a straight line. Okay. So all the
Okay.
strong one you tend to see a straight line, and then those you don't see a straight line but quite like a shape, then is moderate. Okay. And then this is too random. Okay. All right. So let's look at the example. So over here, what you have is this. You have this. Let me get rid of this. So you have ln A, B, and C, and D. All right. Compound X and ln growth. Okay. So what you have here is X and Y is 1, 3, 2, 3. So basically, this is your X and Y. Okay. Once you get your X and Y ready, okay, then you get your X minus X, the mean.
Right.
Okay.
Okay.
So you will get this X minus X. I mean, yeah, you will get the X minus the mean X for each value of X. Okay. And you also get the Y minus Y mean for each value of Y. So once you
Okay.
gather this table, then you can times them together. Why you times them together? Basically because you want to fit all the numbers into this formula. Okay. So once you manage to gather this table, then you just have to fit this data into this formula, and you will realize that the correlation coefficient is 0.969, which means the question asks the correlationship between the compound X and the lone growth. What the question here tries to ask is whether this compound X, which is a chemical, whether
Yeah.
it will help, which compound X here helps the lone growth. Okay, so if you have a very high correlation coefficient, that means the more compound you put in, you will get more lone growth. This is what this number is trying to tell us. Okay, so 0.969 is a very strong positive correlation between the quantity of compound and the lone growth. So this suggests that more compound, greater the lone growth. Yep, this is exactly what I tried to explain just now. More compound, that means the more compound you use, more chemical you use on the lawn, so the lawn growth is higher. But normally, do you want your lawn to grow that much? Or you want the lawn not to grow that much?
No.
Yeah, so you don't want to mow the lawn yourself, right? So you want the lawn to grow, I will say, it's better for them not to grow. But if they don't grow, it doesn't look green enough, so that's also not good. But you just want it to grow very moderately. So yeah, so then you need to find a sweet spot. How much compound you put in, okay? If you put in more, your lawn growth is going to go very high. So that's not what you want, all right? So over here, weight and maximum speed, and weight versus sprinting speed. And in this case, right, over here you can actually use your technology. Okay, you can actually use the technology. So the technology is, if you are using this Casio, this model calculator, what you need to do is you need to key in the table of values here, and then you go and use the linear regression function. Okay, and then you will get all these values. Wow, A, can you see that A is actually the gradient? Can you see?
Yeah.
Yeah. So let me make it bigger. So the A here is actually the gradient, okay? Minus 0.26 is actually the gradient. So with this means is a downtrend. And the B here is the y-intercept, which is 44. And R square here and the R here is R. So basically they show you different calculators, and then you will see the same thing, okay?
Yeah.
So using technology, the R correlation is minus 0.813. So this shows a strong negative correlation. Okay, this means like the weight is higher, the sprinting speed is lower. Okay, so since it's between this range, so you see moderate negative. So basically, you need to refer to what? You need to refer to this table. Once you get
Okay.
the correlation coefficient, you just refer to this table to make a comment on the correlation. Okay,
Right.
very simple. Okay, before I move on, so we can take a break. Then once we come back, get ready your calculator, because I think we need your calculator. Besides,
Okay.
later on we will use one question two to do it manually, but subsequently we want to use a calculator. Okay.
Right. Okay.
So your calculator. I'll see you in a while.
Sure.
Okay. See you in a while. So to draw this, let me get rid of this, the one behind. So to draw this, okay, what I need to do is 2, 4, 6, 8, 10. So 2 is 10. So let's say this is 5, this is 10, this is 15. Oh no, 10 is the max. So I don't need, I need to change my scale. 10 is the max.
Right.
So 2, 4, 6, 8, 10. I think this scale is much better. So 2 is 10. So it's here. 5 is 6. 5 is here. 6 is here. 7 is 5. 7 is 5. 5 is here. You know what? 5 is 4. 5 is 5. 5 is 4. 5 is 4. Here. Let me see. 5 is 4. Then 7 is 5. So 5 is 6. Okay, good. And then last point, 5, 4. Last point is 8, 3. 8, 3 here. Okay. So with
Yep.
this, if I were to insert a best fit line myself, then let's see. Yep, this will be the one. All right, this will be the one.
Yep.
Okay. And I hope you can see that. Yeah. So now calculate the correlation coefficient by hand, which is this. Okay. But bear in mind, I only make use of the first 4 pairs of numbers because my Excel functions are pretty limited. Okay. I think in fact I can actually change it a bit. I think I can change it a bit. Let me see if I can change it a bit. So add another pair and see what I need to do. Wow, nice. Oh, I get all the values. Can you see? Excel is doing an amazing job. They know what I want. Can you see that?
Yeah.
I just insert 8 and 3 and then it gives me that correlation coefficient automatically, which is minus 0.89, which is like minus 0.9, which is a very, very strong negative correlation, okay, as demonstrated by this straight line, right? So this part done. First part and second part is done. Describe the correlation between A. So yeah, so it's a strong negative correlation. Okay, so as the age increase, the number of doctor visit decrease to a certain age. Okay, over here we are talking about what? We are talking about 10 years, up to 10 years old. Okay.
Okay.
So what I'm trying to say is, we are not talking about up to 80 years old because when people reach 55 and above, the number of doctor visits should jump up.
Skyrocket. Skyrocket.
Or maybe they don't visit the doctor much because they have to stay in the hospital. Yeah. So
Yeah.
just once and for permanently. All right.
Permanent.
Just one doctor visit, or then that's it. Okay. So up to 10 years old. Okay. That's why yeah, age increase and the doctor visit will decrease. We are talking about kids lah, basically. Huh? Yeah, it makes sense. So newborns visit the doctors very, very often because they had a low in meal and they were just born. So yeah, all right. Oh, but one thing I really appreciate Excel is they are doing an amazing job. I mean, just need to key in the numbers and then they will automatically give me the result here. Okay, so something is very interesting about Excel. Okay. Okay, they deserve to be among the top 5 companies in the world then, Microsoft.
Yeah.
All right. So the same thing. So for question 4 here, I can actually just insert another table of values, right? And then the scatter diagram, I think even the Excel can give me the scatter diagram. Let me check it out. Let me try it out for this. Let me get to Excel. Yeah, so I'm showing you how you can actually use Excel to do this kind of question instead of PowerPoint. So this is the one. All right. So let me erase this first. This is not needed. Not needed. Okay. What I need to do now is very simple. I need to key in the values. I need to key in the values to the table. Okay. Let me just use the mouse. Get rid of all this. Not needed. Have you used have you used Excel to do scatter plot before? Maybe not.
No.
Okay, yeah. I know. I think very few students use Excel to do calculation. But I always show you. I always use Excel to do calculation. Excel is my calculator, by the way. Let me put it aside. Okay, my job now is to oh, I'm so sorry. So I should get this out of the way. Yeah, pretty far. Okay, so I need to create more pairs of values. So I need to 25, 32, 27, 30, 39, 35, 24, 30, 36, 29, 35. Yes. I don't need the 11th pair.
Yeah.
Get rid of it. This is 25. Then this is 100, 70, 35, 35, 38, 105, 70, 35, 75, 40. Okay, good. So let me double check. Let me double check the average. Okay, so let me get this. Let me make this one. Get rid of this. Yep, so I need to extend this average. And then I need to extend this average as well, right?
Yep.
And now, yeah, just double check. Good. So this one is good, and this is times. Yeah, very good. Times, very good. And then this is given by square. Okay, this is square. Okay, everything is good. All right, everything is good. So this is the sum. Very good. Sum, very good. What is this value? Sum as well. All right. Okay, then the sum of this times this, which is, so I can actually put this back. This xy, this is this. Okay, good. So the sum of this is this. Very good. Done. So double check on this. This divide by. Yeah, good. So the coefficient, the correlation coefficient is this. I hope you can see this one. Okay. Which I have answered part B. I have answered part B. But like I say, I want to demonstrate to you if I can actually, this is part B, this is for part B.
Yeah.
Or like I say, I want to demonstrate to you whether I can use this Excel to get your scatter plot. We try scatter plot. Oops, I need to do this first, right? Or this, you see, insert recommended. Yeah, here. Can you see?
Yep.
Wow, Excel is very, very powerful. Can you see this? Okay.
Yes.
This is a scatter plot given by this. And
Yeah. Okay.
wow. Yeah, that's it. And now Is there a regression thing here? I've not tried before actually. I've not used this to get the regression. I have not tried that before. Let me see. Insert chart is done. This is spotlight. A mini chart place in single cell. No, this is not what I want. Looks like okay. It's limited by my knowledge in Excel. Okay, nothing to do with Excel. Okay, I don't know how to get the best fit line. Okay,
Right.
yeah. But anyway, I think it's powerful enough. Okay, I have answered what? I've answered draw scatter plot done. Here, this is A,
Yeah.
this is B, and then describe the correlation. The correlation is almost perfect, you know, negative, almost perfect, negative correlation, right? Very, very close
Yeah.
to -1. Correlation. Why? Let's see. It says the temperature and then drying time. Temperature and drying time. So temperature higher, so drying time is lower. Okay. So this is about what? Oh, it makes perfect sense. You know why? Because you want to dry your clothes. You want to dry your clothes, right?
Yeah.
So these days, how you dry your clothes? So of course, you go and like let the sun dry it, right? So if the temperature is higher, of course the time to dry the clothes is lower. So we are actually using this what? We are actually using this phenomenon. We're actually using this phenomenon to actually, you know, the heaters and those are what do you call it? They call it no clothes. What do you call that? The washing machine, and you can dry the clothes. Air dry,
Dryer. I just call it dryer.
dryer. Oh, okay, so they have the air dry or you know things like that. You know what they do? So basically they just blow plus heat up the clothes or somewhat like that.
Yeah.
Yeah, yeah. They basically they create a heated environment within the washing machine, and they blow it. So by blowing it, by increase the temperature, uh, by doing these two, the time to dry the clothes is faster. All right.
Yeah.
Okay. So I have demonstrated to you how you can actually make use of Excel to get your scatter plot, in your this uh, correlation coefficient. Then of course with that, then you can actually describe. Describe is pretty easy once you get the correlation coefficient, because all you need to do is you refer to that table. You see
Right.
that table. Where's the table? This table. Okay, this is the table for you to like describe that the scatter plot. Okay, good. Let's move on. Lines of best fit. Yeah, lines of best fit. In calculate the mean. Okay, I have calculated that already. Opening the problem. Dun, dun. The line of best fit passes through. Okay. So the example they demonstrated here, the line of best fit, right, is actually uh is done by a person, meaning like you just draw the best fit line, which is like
Right.
what I did just now. So let me go to the question we do just now. Hey, how come everything is gone? What happened? Where's our stuff? It's gone, right? Oh, it's Excel. I'm so sorry. Yeah. We are not using a PowerPoint. Yeah, you're using Excel, right, just now? Yep. Okay, good. Here. Okay, so over here, right? So you have all these points. So what you can do is you can actually, I can insert the best fit line now. It can become subjective. Okay, this might be the best fit line. Okay, this might be the best fit line, or I
Yeah.
can actually, okay, so sure, okay. Then next what you do is you, because the best fit line, right, it it has to um, align with this y equals to m. It must follow y equals to mx plus c. Okay, and our job is
Right.
to find out the m in this case. So to find out the m, we need what? We need the y1 minus y2 and x1 minus the x2. So what this
Right.
means is we need to find out the 2 points. Okay, which 2 points you pick? I will pick this point. This is your 25 and 100. And then I can pick
Okay.
another point. I don't want to make life difficult for myself, so I will just pick this point. Okay, assume this point is
Okay.
also on the line. So this point is my, wait, this point is also a bit hard to, I think I choose another point. This point is also a bit hard to tell what point is this. So I choose, let me extend this line. Let me extend this line. Okay, good. Okay, so I will say here is 40, this is 42.5. So I will say this is 44.
Yeah.
And this is 44 and 0, right? So with this, I can actually find my gradient. The y1 is 0, y2 is 100, x1 is 44, and the x2 is 25. So this gives me, let me make it smaller. This gives me minus 100 divided by 19, right? So let me make
Yeah.
use of Excel. But I need to use the mouse. So minus 100 divided by 19. So you get minus 5.2. Okay, this is for the gradient m. Okay,
Okay.
and the c. For the c, what we need to do is we need to sub in the y, m, and x. All right. So y, I will pick this point 100. The m is minus 5.26. X is 25. So the c is plus c, right? So c is equal to, I need to use Excel. So c is equal to 100 minus the 5 point, this times 25. So the c is 231.579. Okay, so this means this whole equation of this best fit line is actually equals to minus 5.26 x plus 231.579. Okay,
All right.
all right. Then yeah, that is what this question is about. Okay. Yeah. So
Yes.
over here, they are also using. They also draw the best fit line manually, and then after that, they will choose 2 points to get the gradient. Can you see? And then
Yes.
once they get the gradient, then they find out the c. And in fact, over here they can read from the graph for the c. Over here is about 18. But in my case here, I hope you can see I cannot read the C from this graph because it goes out of the screen. That's the reason why I need to find out using manual calculation. Okay. But
Yeah.
if this line it hits the y-axis here, and then you can just read off the scale. Okay. But I can't in my case. So once you get this, so this is the find the equation of the line. So yeah, so this is the equation of line for this one, and my Excel here is this is the equation This is the equation. Okay, for this line.
Yeah.
Okay. Yep. Pretty simple. This is manual calculation. Okay. Of course, if you have your graphical calculator, what you need to do is you just have to key in this part of thing.
Okay.
Okay, and then you just use linear modeling. Then, yep, just now I think we demonstrate. We have seen 3 examples of calculators, right?
Yes.
Yeah. So that three calculators can actually help you graph and you will get your gradient. Yeah, these 3. Okay, you will get your gradient, you will get your y-intercept, and you will get the r square, which is the coefficient square, and then the coefficient. Okay, so use your calculator. Calculator is very fast. In fact, I think Excel is also able to give me these statistics, all the numbers here, but it's due to the limitation of my knowledge in Excel, so I somehow I have not figured it out yet. All right, maybe next lesson I can demo to you how I can use Excel to get the best fit line and their y equals to mx plus c as well. Okay.
Right.
Okay, let's move on. So once we move on, right? Move on is basically what I have demonstrated just now. Okay, which is, let me get this out and put it into this Excel. All right. So the first thing, all you need to do, scatter plot, very easy, right? Key in all the values. By the way, I'm doing A. I'm doing A now. 2, 3, 3, 4, 5, 7. And then to get the scatter plot insert, then how come this time they give me this? I want to get scatter plot. Yep, this is the one. Okay, this is the scatter plot.
Right.
So I have done this part. Draw a line of best fit incorporating the mean point. So we can actually find the mean point first or so. Okay, so the mean point is the mean of x, the mean of y. Okay, so to find that, let me use Excel as well. Average of x. Let me do it here. Okay, it's 4.5. Then the same thing. Let me do it for y. So 4.5 and 4. Where is 4.5 and 4? So
Right.
4.5 and 4. Okay, I can do this. So instead of this, no, I can incorporate this. Let me see. It's here. This is the point. Let me point out to you. Can you see this is the point?
Yes.
So shape no view. Okay, this is the midpoint. Mean point. I'm sorry, mean point. So now what you do is just draw a line, best fit line, which you think is the best fit line. So it can be quite subjective, but let's try our best. All right. So this is our best fit line. Okay. Then now find the equation of the line you have drawn. So the line I have drawn is this one. Okay. In order to find the equation, so the equation follows y equals to mx plus c. I
Right.
think in this case, I think the okay. So I need to get 2 points to find the m. Okay. The point I get, I will definitely choose this point, which is 4.5 and 4. Okay. And the next point I choose is, I will choose, I'll probably choose this. So this is 2.5. This is 2.5, right? So it's 2.3, yeah? I would say 2.3. It's 2.3 and 2. 2.3 and 2. Okay, so the m is equal to y1 minus y2, x1 minus x2 is 2 over 2.2, right?
Yep.
Yes. So just use calculator, no, use Excel to figure it out. So 2 divided by 2.2, 0.90. Right?
Yep.
And then for the C, in fact, I can cheat a bit here. You know why? I can just tilt the line a bit, then it will hit the it will hit the 0, right?
Yep.
Yeah. So okay, what this means is that means different people, because different people have like I say, this is very subjective. Like the best fit line. If you ask people to insert the best fit line, 3 out of 3 will give you 3 different best fit line because it's very subjective. Okay, so that shows like different people will have different y equals to mx plus c. Okay, so in this case, if I tilt the line a bit, I will get this as my line of equation of this line, my best fit line. Okay, so another person might get another equation of the best fit line. Okay, but generally the correlation coefficient, okay, it should be quite close between different people. Okay,
Yep.
that's one thing. Another thing is this might be different, but the gradient is within a certain allowable range. Okay, which means if my gradient is 0.909, right, the other person's gradient won't be 0.1. Okay, if the other person's gradient is 0.1, that means too far off. Okay, that person is, I'm assuming I'm right. Okay, I'm assuming I'm right first. Okay, I'm assuming I'm right. So if the other person gets the gradient is 0.1, right, that means that the other person is definitely wrong. Okay, but the other person, he can actually get 0.8 something, you know. Okay, the gradient might be 0.8 something. So like I say, 0.8 and 0.9, which is my gradient, I will say that these two are within allowable range. Okay.
Yeah.
Okay, and the person should not get negative. Okay. Okay. So this is what I'm trying to say. Different people get different equations of the line, but it should be within allowable range if we are using the manual method of finding equation of the line. Okay.
Right.
But if all of us, we use technology, okay, we use technology, that means we use the calculator, graphical calculator, the 3 of us should get the same equation of the line. Okay, because we are feeding the calculator with the same table of data.
Right.
Okay. So
Okay.
you have a question for me?
No.
Okay, if not, then we can conclude the day here.
Okay.
Okay, bye-bye. So
Right.
see
Bye
you
bye.
next week. Okay, bye-bye, take care.
Bye bye.